All right. So before we get into finance itself, I just want to talk very briefly about the work program that I've given you. So the plan is to do parts A to E before the school holidays, and I'm going to set a couple for holiday homework as well. Okay. So you will have some holiday homework. And the other thing I want to draw your attention to is I'm going to assess this topic differently. I'm not going to set a test. I'm not going to set an assignment. Instead, you're going to do what's called a mathematical investigation. It's going to go for a week. It's going to go for 4 periods. Now, you might wonder why we're doing it that way. The purpose of this task is to prepare you for the SACs next year in Year 12. So my Year 12 class just started a 5-period SAC today. And it's all extended response. There's no multiple choice questions. And it's only 3 pages, but they will write for about 4 hours. So the idea with these tasks is that they are open-ended. We let you make the choices, and there's no one correct answer. So it's perfectly fine that you all do different things. As long as you justify what you do and choose something appropriate mathematically, we'll give you full marks. So VCAR has introduced this format this year for Year 11s to help you get ready for Year 12. So I've chosen to do the investigation on finance because this is one of the harder topics. So I want to give you time to do the task. So the idea is that when you do this, you're not pressured for time. You have plenty of time to play with the maths and try different things. So even though it's 4 periods, you probably won't need all 4 periods. If I write the task well, you should all have plenty of time to do it. Okay? So don't think it's a rigorous 4-hour exam. It's meant to be really doable. Okay, but just letting you know, it's going to be open-ended and extended response only. The other thing I'll say is this is the second topic in Year 12. So they spend a whole term on statistics, and then they spend about 7 to 8 weeks on finance. So if you're thinking of doing Year 12 next year, you want to have as much control over this topic as you can because it goes pretty fast next year. But we will start slow today. I think you'll find that today's class is pretty doable. So the first thing I want to define is a sequence. Sequence. So that's your heading for today. Think about, let's imagine you're outside of maths. If I give you the word sequence, what comes to mind?
Like Star Wars. Is that like sequels? Oh, yeah.
Sequels, a TV show. Not
sequence of the little shiny sequence like you have on like a spot.
Have you never heard of that? Like it's like glitter, but like it's like sequence.
Like chunky glitter in a sense.
You've never heard of that?
No, sorry.
Yeah, glitter.
No, sequence.
I'll have to look that up later.
Have you seen those pencil cases that you can like swap?
Yes.
No.
Look at an awesome graph. There's those little plasticky yellow like balls.
They're like chunky glitter.
It's true.
Clearly, I'm not as cultured as all of you.
Just sequence up.
I can do it after the video recording's over. No. So those of you listening online, apparently I need to know something about like fashionable sequins or something.
Yes.
And I don't know that. Sequins, okay. So I'm not talking about glitter here. I'm talking about a different kind of sequence. So if I say there's a sequence to something, what comes to mind? Consecutive? Change? Okay. Yep. I think you've got the idea. Okay. All right. Silly example, right? There are 2 tasks that most of you do every day. One of them is have a shower, and the other one is to like take your clothes off, and the other task is to put the clothes back on. Does it matter what order you do that in? So, so do you shower first, and then undress, and then redress?
Yes.
So you shower with your clothes on. Okay? So there's a sequence or an order to that, okay? So you got a point.
It's the shower.
All right. Okay, clearly it was a bad example. Now, your lessons is writing down lesson please. All right, so I do want you to write this down. A sequence is an order of listed numbers. So, for example, 2, 3, 4, 5 is a sequence.
Yeah, can you please put one in the front?
No, because I don't have to. You see, actually, we can start sequences wherever we like. Okay? All right, so can you see here? I've got the same numbers 2, 3, 4, and 5. And in the second one, I've changed the order. All right, now, because I've said a sequence has order, these two sequences are different. Okay, so even though they have the same numbers, because they are written in an order that's different, we're not going to say that they're the same. So, let me give you a kind of roadmap for our tour for the next couple of months. Well, not a physical tour. All right. So year 11, listening. So far, I've just introduced a list. And in all of the lists that we're going to look at in this topic, there's always going to be a pattern. You might already notice a very obvious pattern in those two sequences. We'll talk about that in just a moment. We're going to introduce some new mathematical language to describe those patterns very, very precisely. That's coming next week. For now, we just got lists of numbers. We're going to look at the pattern, and we're going to ask what comes next. Later on in the topic, once we've got the new language, we'll apply this to some financial applications, mainly simple interest and compound interest, which you learned about last year probably. But this time, we're not going to use formulas as such. We'll model it using patterns like this, sequences. Okay. So in today's exercise, what we're really doing is we're trying to describe the pattern. And it's not meant to be a trick question. It's meant to be the obvious pattern. So let's start with this example. Bruce, what do you think the pattern is here? Speak up. Increasing by 1. Right. So AJ, what numbers will come next? Yep. Couple more?
7 and 8.
Excellent. All right, Mac, can you tell me what the pattern is here? Yep. All right, John, can you tell me what numbers will come next? Great. So I reckon you've actually been doing this for a very long time, from the very early days of Squizio.
I hate Squizio. I always use like online things that would tell me the pattern.
All right, Kalisha. This one's a little bit different. What do you think the pattern is here? Kalisha? All right, do you want a handball? All right, Jess?
It's decreasing by 6.
Decreasing by 6 is correct. All right, so Ben, what numbers are going to come next?
Maths. 26. 20. And then 34.
Yep.
This is my brain working out loud.
Subtraction is, most people find subtraction harder than addition. That's fine. Okay. So we can go up. We can go down. So is this all right? You feeling comfortable with this? All right. Sure. Not yet, at least. Okay. So no. No, Tara, I would never do such a thing. Yeah.
Hey,
It's called sarcasm.
Yeah, I know.
I would definitely never use it on a teenager who would never understand it.
Wait, was that sarcasm?
No, Ben. No.
You have a secret like Instagram account where you talk shit about. That's so funny. Like they don't.
Okay. So I want you to write in the top corner of your page that these are arithmetic sequences. So when we go to the next page, the pattern is going to be very, very different to the one on the board here. And we'll give that one a different name. So for now, just keep this in mind because we'll come back to this next lesson. If I add the same number every time, or if I subtract the same number every time, we give that a special name. We call that an arithmetic sequence. Okay? Remember that because if this term will come back again. All right, can I go to the next page? Okay.
Wait, should we write down something like when a pattern what increase or decrease by the same number that is arithmetic?
Yeah. Yeah. I mean, we'll do that again later. So if you didn't get it down, that's fine. Yes, Ben? Yeah, that's fine. Yeah.
Oh, look, you've got a map. Richardson.
You better come back with
Okay. We're gonna do one more page, and then that's it for today. All right. So guys, you need to listen now. Jai, what's up? Yes. Okay, so Jai has jumped in. This is the pattern. We are multiplying by 2. So what did I say on the last slide? Multiply by 2 to get next term. So Jackson, you may need a calculator. It depends. Can you tell me a couple of numbers that come next? Yep. Excellent.
He's played too much of 248.
Okay. So one thing you'll notice immediately. Is that the numbers get very big very fast. See, we didn't get into the hundreds straight away. Now it's blowing up. All right, we'll do one more. That's getting larger. All right, let's go with Lexi. What is the pattern here? Yeah, but Lexi is being asked the question. You have to have a go first. By how is it going up? All right, Ash. Excellent. Okay.
It does.
All right. So normally what I'll do is I will give you a few more terms just so that it's really, really obvious. At this point, most of you may need a calculator, but anyone want to suggest how to get the next number? What should we do? Yep, so can anyone work this out?
250 times 5 is 1,250.
Oh, yeah, it's 1250.
Yeah, I was right. I literally said that. I use my brain for that. You know why? Because 4 250s is 1,000 plus 1 more is 1,200. I would not get. Bro. She's a woman.
All right, and last one. This is where it's gonna. This is where it starts to get a bit difficult. So I'm deliberately going to choose one that's challenging.
Oh, that is so easy. Actually, no, take that back.
Dividing by a particular number.
No kidding.
Yes, we are dividing by a particular number. The question is, which number?
Number.
There's an H number?
So one thing I will say.
Oh, it's 3.
Nope. Okay, so I don't expect you to know how to do this yet. I'll teach you this I'll probably teach you this next week, in our last class. So Maddie.
What if I just don't come back?
Well, you'll still have to catch up. kind of. I mean, the number 9 is involved. So I'm just going to give you the answer, okay? I'll tell you how to work it out soon. So there are two ways to think about this. One way is to say, I need blue writing here. Multiply by 0.9 or 9/10. So 9 times 9 is 81. 81 times 9 is 729, and you'll see those numbers making an appearance there. Okay? So 0.9 is the same as 9/10. Okay? Or you can divide by 10 on 9. So if you don't know that multiplying by 9/10 is the same as dividing by 10 on 9, that's fine. This is not an algebra course, but it would be useful to know that next year. Okay, so maybe I can run a masterclass on fractions at some point. Okay. Now, I'm definitely not going to do this by hand or mentally, so I'll just give you the next few numbers. 65.61.
Well, Ireland just voted for it now, so you know.
Okay? Yeah, I can't do that.
There's mathematicians that can do that easily.
Yeah. There are techniques for multiplying large numbers. I mean, it's not so useful now because it's calculators. All right, so year 11s. I'm basically ready to let you go and have a go at 3A. There's nothing too difficult in this exercise. So it will ramp up pretty soon, but this is your gentle introduction to the hardest topic this year, in my opinion. Okay. So does anyone want to ask a question before you start some work? No? Alright, so you can get started on exercise 3A, please. Please remember that you're going to get a couple of exercises for holiday homework, so try to stay up to date.